very good morning to the new session. Today we are going to discuss about the basic load flow analysis involved in it. Comes under unit number 2, load flow analysis. So in the previous session we come across about your basis, that is what is the need for your per unit analysis and what is the essential requirement to convert your actual equivalent circuit into per unit circuit. These are the things that we are discussing in the last session. Now we are going to analyze our system using our load. So here one of the famous scientists, namely Gauss-Seidel, he proposed the technique. The method is nothing but Gauss-Seidel method. Today we have to learn the Gauss-Seidel algorithm as well as flowchart in this session. So this is my flowchart for Gauss-Seidel method. So here I have to start my system, that is start process is involved in it. After the starting of any kind of conventional programs, my read method. So here the reading here is we have to take our number of buses in the power system, how many number of buses in the power system, whether it is 3 bus, 4 bus, 5 bus or up to n number of buses we have to identify in the reading block. First we have to read the number of buses in the power system. In our electric transmission and distributed, the number of consumers is added day by day, so we are going to estimate the number of buses as n, and you have to second, after reading your number of buses, you have to read the line admittances. So line admittances belongs to your number of buses in the system. Suppose if you are having 2 bus system, means we have 2 cross 2 matrix. Suppose we have 3 bus, means we have 3 cross 3 matrix. Suppose 4 bus, means we have a 4 cross 4 matrix. Likewise we have to determine our line admittances. Either you can find out your method of inspection or singular transformation, the Y bus method. So after finding out your number of buses and line admittances, we have to estimate or read the slack bus voltage. So slack bus determination is very important. In general we have to keep our slack bus as 1 at an angle 0 or 1 plus j0. So it is my constant value or it is my reference value. So in our circuit analysis we may always taking our ground potential as 0 potential or reference potential. Likewise in our power system we have to take our bus as slack bus voltage, and after reading your buses, line admittances and bus voltage, we have to go with your load buses. So load buses we have 2 combinations. One is your real power and reactive power. So the load is in the combination of real power as well as reactive power. And next one, the last reading parameter is generator buses. So in the generator buses we have to find out your actual P and voltage specification and reactive power maximum and reactive power minimum. Here the 2 types of ranges of your reactive power. So at what range to what range your reactive power limit is existing in the power system. So here we have to reading all these parameters. So after your starting is over, you have to read all the buses, line admittances, slack bus voltage, load buses and generator buses. So after the reading process is over, you have to form the Y bus matrix and determine your Y j of k. Here your j stands for 1 to up to n and k stands to 1 to n. So here we have to form our as usual Y bus matrix, either your method of inspection or singular transformation method, and in the next process we have to set our Vp0 as 1 plus j0 expect slack bus. So without your slack bus we have to set our Vp, that is initial voltage is 1 plus j0, and your convergence criterion epsilon is determining here, and after finding out or initializing these values, you have to set the iteration count. So in our conventional simulation methods, we have to set our iteration count as first is in the 0 only. So after the counting is k equal to 0, you have to fix your bus count. So in the next process, I have to fix my bus count. So bus count is depends upon number of buses existing in the power system. Suppose if my p which is equal to 1, I have to check for slack bus. So I have to check whether the bus count is 1 means whether the bus is slack bus or not. Suppose if the bus is slack bus means yes, we have to move to advanced bus count p equal to p plus 1. We move on to the second bus. So after the second bus count is over, check if p is greater than 1. That is, your slack bus is greater than n. If it is yes means we have to evaluate your del v max, and del v max which is largest of del vp k plus 1. Here you have to check your maximum change in voltage is less than epsilon. You have to convergence criterion is lesser or not, we have to check. If it is yes means evaluate the line flow and slack bus power. Finally it is stop. So where we started, I am started with your slack bus. So if it is slack bus means we have to move to yes, the yes statements proceed with your advanced bus count. You have to increment the bus count and your p is greater than n. If it is yes means you have to evaluate your maximum change in voltage. It is less than or equal to your convergence parameter. If it is happening yes means you have to evaluate line flow and slack bus power. Stop. Suppose if it is the convergence criterion is lesser means you have to satisfy this no condition. No condition means that your k equal to k plus 1. So when k equal to k plus 1 means again you have to proceed with your set your bus count, again p equal to 1. The as usual process is going on. Suppose no, suppose the given bus is not a slack bus means we have to check our generator bus. So check for generator bus. If the generator bus is yes means you have to temporarily set the voltage values, that is your actual voltage which is equal to specified values, and you have to check your QP calculator k plus 1. You have to check your reactive power limit. So your QP calculator is less than QP minimum. So if it is yes means your QP equal to Q minimum and treat the bus as load bus. So the value of the Q is minimum, that is minimum of your calculator value means you have to choose the bus as load bus. Suppose if it is greater means you have to check it is your load bus. So again this condition is satisfied means treat the bus as generator bus and calculate your angle del p k plus 1 phase of vp k plus 1 and set vp k plus 1 vp specified at an angle del p k plus 1. Again you have to calculate your del vp k plus 1 and vp k equal to vp k plus 1. Again you have to set your advanced count. Advanced count is going with your p is greater than n. Again you have to evaluate your del vp1. So in this manner you have to calculate your load flow analysis for your entire power system. The main motive of this system is whether the real and reactive power flow is utilized in the proper way in your power system or not. It is the main motive of this flow chart. So it is one of the important question in your university point of view. Thank you. We continue in the next session.